In this video, we're going to dig a little bit deeper into our knowledge or our understanding of factoring. Now, factoring is something that we've been doing for many years now. You can go all the way back to when you were thinking about how would I factor the number 12? Well, I could write the number 12 as 3 times 4. I could also write it as 2 times 6. These are all legitimate factors. Or I could try to do a prime factorization of 12, where I'm trying to write it as the product of, you could view it as its most basic constituents, which would be the prime numbers. And so we've done stuff like, well, 12 can be expressed as 2 times 6. 2 is prime, but then 6 can be expressed as 2 times 3. And so 12 could be expressed as 2 times 2 times 3, which we see right over here. This is all review, and this would be a prime factorization. And we saw an analog when we first learned it in Algebra 1. In Algebra 1, we learn things like, and sometimes this might be in a Math 1 class or even in a pre-algebra class, you'll learn things like, hey, how do I factor x squared plus 6x? And you might recognize that, hey, x squared could be rewritten as x times x, and 6x, that really just means 6 times x. And so both of them have x as a factor, and so we might want to factor that out. And so we could rewrite this entire expression as x times x plus 6. What we just did is we factored out these x's that I am circling in blue. So in general, this idea of factoring, if you're thinking about numbers, you're writing one number as the product of other numbers. If you're thinking about expressions, you're writing an expression as the product of other expressions. Well, now as we go a little bit more advanced into algebra, we're going to start thinking about doing this with higher order expressions. So we've done it with just an x or just an x squared, but now we're going to start thinking about, well, what happens if we have something to the 3rd power, 4th power, 6th power, 10th power, 100th power? But it's really the same ideas. And we could start with monomials, which is a fancy word for just a single term. So let's say I had something like 6x to the 7th. What are the different ways that I could factor this? Pause this video and think about it. Can I express this as the product of two other things? Well, I could rewrite this as this is being equal to 2x to the 3rd times what? Well, let's see. What do I have to multiply 2 by to get to 6? I have to multiply it by 3. And what do I have to multiply x to the 3rd by to get to x to the 7th? I could multiply it times 3x to the 4th. Notice 2 times 3 is 6. X to the 3rd times x to the 4th is x to the 7th. We add exponents when we're multiplying things with the same base. But this isn't the only way to factor. Just as we saw that 3 times 4 wasn't the only way to factor 12, you could also express this as maybe being equal to x to the 6th times what? Well, we would still have to multiply by 6 then, and then we'd have to multiply by another x. So we could write this as x to the 6th times 6x. So there's oftentimes multiple ways to factor a higher degree monomial like this. And there is also an analog to doing something like a prime factorization. When you're trying to really decompose, rewrite this expression as a product of its simplest parts. How would you do that for 6x to the 7th? Well, you could rewrite that. You could say 6x to the 7th. Well, that's equal to, we could think about the 6 first. We know that the prime factorization of 6 is 2 times 3. 2 times 3. And then x to the 7th is just 7 x's multiplied by each other. So times x times x times x times x times x. How many is that? That's 5, 6, and 7. And so some of what we were doing, when I said 2x to the 3rd, what we really thought about is, okay, I had a 2, and then I had x times x times x. And then what do I have to multiply that? Well, I have to multiply that by 3x to the 4th. And as we will see, being able to think about monomials in this way will be useful for factoring higher degree things that aren't monomials, things that are binomials, trinomials, or polynomials in general. And we'll do that in future videos.